Alright, so welcome back. So hopefully by now you've gone through and you've tried all the different graphs in that worksheet, find the domain and range. And I will say it's really important with this to practice. It's easy to look at them and just trying to save time and quickly say, okay, x is going to be greater than or equal to this, or x is between this and this. Look at the answer and match it up and say you're done. But what I need you to do is actually practice writing it out using the inequalities, because that's where a large percentage of the mistakes come in on tests is just people writing the inequalities in the wrong direction because they think they've got it, but they haven't practiced it enough because they've been doing everything visually. So do go through the process of writing out the inequalities every single time you do this, and then check your answer to make sure you've written them correctly. Okay, so looking at this first one here, again we have a sort of a partial line here. So if it helps, do draw out what your domain and range are. So you can see your domain is going to be anywhere from -5 to the right, so x is going to be greater or equal to -5. I've written the formal notation down here, but again on a test I'm okay if you just write x greater or equal to -5. And for range, you can see that we go down as low as +1 and then go up forever, so y is greater than or equal to 1. Okay, with the second one, you'll see the open circle, closed circle thing coming back up again, which we saw in an earlier lesson. So remember, a closed circle means the point is included. An open circle means that the point is not included. So looking at our domain here, I go down as low as -3 and as high as 2, but not actually reaching 2. So what we say is that x has to be greater than or equal to -3. Okay, again, equal to because of the closed circle there, but strictly less than 2. Not less than or equal to, because that would involve including that point there. So x is greater than or equal to -3, but strictly less than 2. Okay, for my range, so you have an open circle there at 2, it's the lowest value, and it goes all the way up to a maximum value of 4. So y is greater than -2, but less than or equal to 4. Okay, and again, make sure you're okay with writing these as inequalities. Let's look at a few more. And you'll see some common themes coming up throughout. It's just a matter of going through how to write certain types of weird situations that come up. Okay, number 3 is another example of a parabola. So you'll notice that with parabolas, x will always be an element of the real numbers to the domain. The only exception would be if it's a real life situation with restrictions on time or anything like that. And for our range, our maximum value is 7, and we go down from there, so y is less than or equal to 7. Okay, number 4 is another circle. So you can see x goes between -1 and 7, and y goes between -5 and 3. Okay, so we get that for a domain and range respectively. Okay, number 5 is a line that continues on forever in all directions, but you'll notice here that while it looks like x continues on forever, if you're not careful, you might notice that there's a little hole here and you might miss it. So it means that this x value right here is not part of the domain. It's not included for whatever reason. Okay, so the way we write that, the easiest way to write it is say x is an element of real numbers such that, and then just list what x cannot be. Okay, so x can be anything but this at -5. Just simply say x cannot equal -5, and that's a way of saying that x can also be everything else. Okay, because otherwise you'd be writing instead x is less than -5 and x is greater than -5, which is technically correct, but it's far easier to write x is not equal to -5. And similarly for y, you can see y exists everywhere except for at this where the hole is at y equals 4. So we just say y is not equal to 4. Okay, number 6, it looks like it's an oval or an ellipse, and you can see that x exists between -3 and 3, and y exists between -4 and 4. Okay, a couple other ones to look at here. There's no clearly drawn closed circle on here, so if it's not on there, assume it is included, so assume that is a closed circle. So what this is actually, it's a transformation of a square root function, which we're going to look a lot more at over the rest of this unit. So you can see for your domain, x exists everywhere from 3 on to the right, so x is greater than or equal to 3. And for my range, y exists everywhere from 5 on up, so y is greater than or equal to 5. Okay. Number 8 might have been a little bit hard to read on your graph. What's actually happening here, so the shape might look familiar from the parent function that you drew on the first day. It's a transformation of 1 over x. Okay, transformation of it, not obviously it's not identical to it. But what you actually have with this graph are invisible lines we call asymptotes, which exist. Sorry, that's not very well drawn. And what these are invisible lines that the graph gets really, really, really close to and forever gets closer to it, but doesn't actually touch it. So I'll show you a visual on Desmos in a second here. What this means is that the values where these asymptotes exist are never touched by the graph. So looking from left to right for x along here, you can might be a little bit hard to see on your graph, but we see we exist everywhere except for at this x value right here, because the graph never crosses this vertical line. So it looks like that's at -3, so we just say for a domain x is not equal to -3. And for a range, you see that y exists everywhere except at this horizontal line, which it can never cross, so y is not equal to -2. And just to show you what the asymptote looks like, I'm just going to put on a graph in Desmos. Okay, so here's a graph of something very similar to what's on your sheet there, and the asymptotes aren't drawn in, so it's a little bit sometimes hard to see where they are. But if I put the asymptotes on there, so you can see, let's take a look at this horizontal one over here. You can see as I zoom in the asymptote and move out left to right, we're always getting closer and closer to the asymptote, but never actually reaching it. Even when it looks like I'm getting closer, I can zoom in right more and see I'm actually, again, getting closer and closer, but never actually touching it. Okay, and the same is going to be true for the vertical asymptote as well. So you can see here, it looks like it's actually about to touch, but once you zoom in, you can see there actually is a gap, and you are getting closer and closer to it, but again, you're never actually going to touch it. Okay, so just be careful of that when you're doing your domain and range. Okay, and last but not least, we have a sideways parabola over here. So for my domain, it starts at 4, it looks like, and continues on going to the right forever. So we'd say x greater than or equal to 4. And as for the range, going on forever in all directions because of the parabola extending out. Pardon my bad drawing, but it is going to extend out there. And so you'll get y is now one of the real numbers. Okay. So last couple of problems we're going to look at here. In this particular case, I want us to just think about the domain only. Don't worry about range. We'll talk more about range of types of functions like this later on in the unit. But strictly think about the domain. And what I want you to think about is what you can and cannot do when you're putting numbers inside an equation like this. So the first one we have here is a polynomial. And you think about a polynomial, is there anything that you can't put into a polynomial? And when I say something that you can't put in, something that might cause an error in your calculator. And hopefully if you think through that a bit, you'll realize, hey, there's nothing I can't put in there, right? I can take any number to the power 3. Okay, I can multiply any number by -7. So I'm just adding a bunch of numbers together. So there should be no restriction on this domain here. So let me take a look at the graph here just to confirm this. Okay, and I can see in Desmos there that you see there's no restriction on this graph. It's going to continue on forever up and down, and it's going to continue on forever left and right. So in this particular case, as I'm simply concerned about domain, it continues on forever left and right. So I would say that my domain is simply x is an element of the real numbers. Okay. As for the next one, what I should be looking at here is, okay, here I'm dividing by 8 minus 11x, but when there's dividing, is there anything I can't divide by? So think about it for a minute, and hopefully remember that, hey, wait a minute, I cannot divide by 0. So cannot divide by 0. So I'm going to have a serious problem if there's any value of x that makes the whole denominator 0, because then I have 2 divided by 0, and I know I can't do that in my calculator. So if there's any value of x that makes the denominator 0, it's going to be a problem with my domain. So looking at this, okay, where is 8 minus 11x equal to 0? Let me take a look. 8 minus 11x, let's make it equal to 0. Okay, and then I can just solve for x. So if I add 11x to both sides of the equation, I get 8 equals 11x. So x equals 8 over 11. So what that's telling me is if I put x equals 8 over 11 into this function, my denominator will become 0. So I'll have 2 divided by 0, which I know can't happen. So my domain here is that x cannot be equal to 8 over 11. I'll confirm that by looking at the graph on Desmos. Okay, and you can see here, when I put that graph into Desmos, it looks like there's a certain x value that the graph cannot touch. And just to confirm it, I put in the asymptote x equals 8 over 11, and you'll see that, again, the graph can never actually touch 8 over 11, just get really, really close to it. So that gives me my domain. Okay, and last but not least, here I have a square root function. So ask yourself, is there anything I can't take the square root of? Well, you saw on the first day when you were doing your parent functions that you cannot take the square root of a negative number. So any x value that makes what's under the square root negative is not going to be a valid part of the domain. So what we actually need then is what's underneath the square root, which in this case is 5 minus 3x. In order for it to be a valid part of the domain, it has to be greater than or equal to 0. So 0 or something positive will create something that's part of the actual function. But if it's less than 0, we're going to have a problem. So what I need to do then here is just simply solve this equation. And thankfully, since we did lesson 3 the other day, we have learned how to solve linear inequalities. So what I'm going to do here is subtract 5 from both sides. So I get negative 3x is greater than or equal to negative 5. Okay, and then I'm simply just going to divide both sides of the equation by negative 3. And remember that I'm going to have 5 over 3 over here. X is isolated. But anytime I divide by a negative sign, or multiply by a negative sign when I'm solving an inequality, the direction of the inequality changes. So it's going to be x is less than or equal to 5 over 3. So any x value exists in this function as long as it's less than or equal to 5 over 3. And just to confirm it, let's take a look at Desmos. Okay, and there you have it. You can see that when x equals 5 over 3, or about 1.667, that's the highest value the graph reaches for x and then continues moving out to the left. Okay, so what's important when you think about the domain strictly from equations is, again, just think about what cannot be done inside the function, and that will give you your restrictions on the domain. Okay, so that's it, that's all. So I'd like you to do, there's a couple of questions in the textbook worth trying. At the bottom of that worksheet with all the graphs, there's some real life situations on there that you need to find the domain and range from. So you might have some restrictions on, if it's a banquet hall, number of people that could fit in it, or there might be restrictions on your cost. If it's looking at an equation of a parabola, like height versus time, you know that time can't be negative. Maybe height can't be negative either, depending on the situation. So I'm going to have to think through those situations to see where your domain and range might be. And then I want you to go back to the very first day when I had you complete all those parent functions. I just want you to find the domain and range for all those parent functions, and we'll take those up next class. Okay, so that's it. That's all.